Yo, welcome to my beautiful video. I got my code here. Just wanted to show you around it a little bit. So this is, I call it the Carroll solver. It's based on this word game from Lewis Carroll. But essentially what it does is it's got a UI element. So this is all auto-generated code up here from a designer, and then it the actual main program just launches that UI, which in turn invokes on like the submit button push. It's going to invoke this word solve function, which is all where the real magic happens. So this is the AI agent down here, this word solve, and what that essentially does is, oh, and just to be clear, I'm not sure if I can send you this code because, or I can send it to you. I'm not sure if it'll run. Reason being, this is all dependent on PyQt5, which, I mean, you might have it installed. I don't know. This is a very specific thing to need, and it took me a while to kind of figure out how to get all that set up. So I also have a portable version, which I can show you later if that is something that you'd be interested in receiving. But for now, my understanding is I just need to show you a video, so I'm not gonna worry about that. But yeah, the word solve, all that does is it does some basic input verification of what you type into the different fields on the UI, and then it's gonna run that through this essentially solution finding algorithm, which what this does is it's a bidirectional search. So it's going to look from both the top word and the start word and the end word, and it's going to look at all the possible different single letter variations from that word, which are also a word. So it in order to do that, it needs to have a dictionary, which you can actually provide. You provide a dictionary text file up here. I've got one right now. It's got like 300,000 words, which is it's quite a lot of words. You end up with some pretty like archaic and unusual kind of words in here, but it does make everything go a little bit smoother, especially when you have like longer words that you're trying to get between. But yeah, if you don't know, the goal of the Lewis Carroll game, or Lewis Carroll's word game, is that you change one letter in a word, and the resulting combination of letters should also be a word, and you just keep doing that over and over and over again until you find a particular goal word that you're trying to get to. So you just provide a start word and an end word, and it tries to get between them, changing only one letter at a time. But the difficult part is that it has to be an actual word, and that's where your dictionary can make a big difference. But the way that this works is it just checks out single letter variations from your start and end word, and then it does essentially a breadth first search from both the top and the bottom at the same time, and then it looks for intersections between each consecutive layer of that breadth first search. And so in order to make that happen, I've got a couple different classes that I define. One is just the word. So this is basically just a wrapper around Python's default string, but it has a couple of extra pieces. So for one thing, it's got this hierarchy. So what it does is every time you generate a new word from a previous word, it will record the entire history of where that word has come from and save it in the new word instance. So what that allows you to do is, first of all, it allows Python to not garbage collect the old words that you used earlier in the search. But second of all, you can use it to trace back when you actually find in the binary search, when you find your solution where the two, or the bidirectional search where the two layers eventually come together. That point is going to have to be traced back to the original word to find out what words you had to do in order to get there. And so this allows you to do that. And then the other thing that I added to this sort of string wrapper is it's got a method that automatically lets it generate every possible like single letter variation from that word, and it's pretty straightforward. As you can see, I've got it, it's all nicely commented if you actually want to read through it, but basically it's just going through all the different one letter combinations, and then in here all it's going to do is, after it finds all those combinations, it compares them to a dictionary, which is another class that I've defined. Close that notification. So the other class is, all it really does is it takes in the word list that you provide, and when you initialize it, it reads it all into this giant library, or into this giant dictionary in Python, which is basically a hash map if you don't use a ton of Python. But all it's doing is it's associating the hash code of these words that are being initialized to a pair of false values, a pair of Boolean values which track whether the word has been searched already. Because if I didn't track whether the word had already been searched, the search would just bounce back and forth between two words forever, and that would obviously make the program take forever. Or it would expand the number of words to be searched at each step by a substantial amount. And so what this does is it's got this nice little method that allows you to check if it's in the dictionary, but also if it's been checked before. So whenever you check a word, it first verifies that it's in the dictionary using this little method down here, this little helper method, and then it checks if the word has been checked yet. And if it hasn't, then it says that now it has, and then it tells you that the word is in fact a valid and eligible word in the dictionary. So the key to this is the realization that when you're doing a forward or backward search for like a breadth first search, there's no point into ever checking a word that's been checked before, because the solution that you will find from that word, any solutions that could come from that word, will be at least as long as the last time you checked it. So there's no reason to ever allow a word to be checked more than once, which means that this search can go substantially faster than if you were trying to exhaustively find every single possible way that you could be searched, that you could be achieving that solution. Because, of course, there are infinite ways that you could achieve a solution just by bouncing back and forth between two words over and over again. So yeah, once it gets that, it essentially just takes these consecutive lists of word variants, and eventually there's some intersection between these two sets, one coming from the starting word, one coming from the ending word, and at that point it just takes the two words that impacted, or two of the words that impacted. There could be multiple pairs, but it just takes any two of them, or any single pair, and it traces back their histories using the hierarchy function that I showed you earlier, and then it just pumps those out, just returns the final solution here after getting the original hierarchies. And there's some little details in here about whether it impacts the growth list from each side, or the list that was there before, or like there's a couple of different things that can happen, but pretty much that's how it works. And so now I can just run it for you. So we have just a simple UI, say from word Lewis to Carroll. Now, technically you're not supposed to use proper names, but I know for a fact this works. So, because there are adjacent words that are not proper nouns. But as you can see, because we've got a lot of these kind of words that are, these are not like common English words. A lot of these are really just old words. Like if I look up Harry's, I have no idea what that is, but I can, I can Google Then a pairs or pairs. Oh, it's a pair. Oh well, that's a little. Oh, let me look up. What is a Carroll? I just never have seen. What is life? Okay, so yeah, apparel is an old term for apparel, like clothes. Yeah, all uses of this word are obsolete, but it's still in the dictionary because I've got a really, really big dictionary. So you could, if you wanted to, replace this with a smaller dictionary to get more like common English words, but you wouldn't have to. Like, you don't have to do that, and I'm not going to do that because there's no point. I'll just let it come up with obscure solutions. I like learning new words, even if they're old. You could even put in a dictionary for a different language, although the issue with that would be if it has a different alphabet, you'd have to change this alphabet variable over here as well, because this does do some input verification. There are some limitations to this, like if I put in a capital, I believe it'll still work. Yeah, but it just lowercases it. But if I put in something that's different lengths, it'll give me an error. If I put in something with like numbers, it'll still say they're not valid. But I can put in anything. I can put in world, and it'll give me that solution. That's a little shorter solution. I can put in something like find to word, and there you go. Easy. You can even put in longer things. Let me think of a good longer one. So starts to finish. This might take a minute. Once you get to about 6 letters, it starts to take a while, especially if the words are like really grammatically dissimilar. So like here, there's not really many shared phonetics between them, and the vowels are in different places. So yeah, I came up with a solution. So as you can see, it had to search a really long way, and the search is not necessarily linearly related. Like the length of the solution is not necessarily linearly related to the amount of time the search takes, because every layer it has to go, of course, it has to search more words on that layer, because the search space is just going to get bigger and bigger and bigger. Now it can fail if it doesn't have, if there's no words in the dictionary that can meet the needs. So if I say like Shia LaBeouf, and then word means how many letters is that? Wait, did it work? Yeah, so even though there's the same number of letters, obviously it's not going to be able to find a connection between these because there's no adjacent words to these. So it will give this little message that there's no solution found using the current dictionary. There are some word combinations, especially if you get into longer words, where it just can't find any solutions. Obviously, this is a pretty obscure example. But if you were trying to turn like run file into Carroll, that might be possible. Give it a try. Well, let's. Yeah. The message doesn't change. Let me see. Yeah, so it's got no solution found. Because these are just too different and there's not any potential connections. They're 7 letters long, so it's a pretty long puzzle to do. But yeah, that's basically the program. I've also got a portable version. I can show you. Let's see. This is my spider directory, but over here in distribution, this is just essentially a portable executable for Win64 that I got via PyInstaller, and is the exact same thing. and it does work. So if you have a Windows x64 computer, I can send you this if you want, but it have to be a big zip file. Yeah, so hopefully this is informative. Hopefully this is sufficient. I know that I'm trying to submit this kind of early because I would love to get some feedback on it. If there's anything you want me to correct or add in, I tried to comment it as best I could so that you'd be able to easily break down what's happening. So yeah, thanks for your time. Have a great day.